my algebra doing friends. I think this is the last section of chapter 9 that we have to go over, 9.5. And it's on solving quadratic and rational inequalities. And so instead of equals, we're solving things that are greater than or less than or equal to. The method that we're going to be looking at is the boundary method. And they do a slightly different method in your book with the signs, but they start off the same way by looking at where it's equals, and so you can look at that, and then after you find the boundary points at equals, you use whatever normal methods to do that, and the quadratic formula or a factoring or the square root method. Then you put your boundary point on your number line, and you use a closed circle if it's greater than or equal to, or less than or equal to, and you use an open circle if it's greater than or less than. And the reason for that is because equal to means that that equals was a solution. So we put the solid circle to show that that is also a solution. We put the open circle here to show that it's just the boundary between the solutions and the non-solutions. Then you want to test a point not on the boundary to see if the region is a true region as a solution to the inequality. And I test every region. And so you'll learn some theorems in Math 1 that can make it where you don't have to test every region. And so I'll let your Math 1 teacher show you that. And so on this one here, I made a typo on here. And so I'm going to write here. I'm throwing pens away like crazy. And so I'm going to write right here, type O. Okay, so this really was x squared minus 4x is less than or equal to 32. And somehow the 2 got lost on there. Anyway, so now we have this. So what I want to do is I notice that it's quadratic inequality. So here it's quadratic, but it's inequality. So how you solve quadratic inequality is by finding the boundary. And the boundary happens at equals. So I want to solve this. And how I solve this is because it's quadratic, is I either use the square root method, not on this one because of the middle term, right? Or I use the factoring. Well, in order to do factoring, you got to get 0 on one side. So let me take away 32 both sides so that I get 0. And so I'm thinking, will this factor? Well, when we think about it, right, 8 times 4 is 32. But when we subtract 8 and 4, we get -4. So yeah, this will factor. So this is x minus 8 times x plus 4 is 0. And so our boundary points are x is 8 and x is -4. And because this was greater than or equal to, we know that we're going to make solid circles, because 8 is actually a solution and -4 is actually a solution. So I'm going to put this on my number line. And you want to put these in numerical order. So you don't get to just put them in whatever order that you want. You want to put them in numerical order. And so I've got my solid circles. And now I want to know, for my original inequality, x squared minus 4x is less than or equal to 3, is something in this region, like -5 is in this region, a solution? And so this is where I'm going to do my test points. So I'm going to test -5, and I'm going to test in the original inequality, x squared minus 4x is less than 3. And I'm going to put in -5 and see, is it true? And so let's see here, that's 25 plus 20, and so that's like 45, less than 3. No. Nope. So this is a nope in that region. Now I want to test in a region between -4 and 8. So I'm going to test 0. That's my favorite point. So what squared minus 4 times the what is less than 3. And we're going to put in 0. So this is 0 is less than 3. And that's a yes. So this is true. And so this is my solution region in between -4 and 8. And now I'm going to try like 9. So when I put in 9, I get 81 take away 36, which is still bigger than 3. So this is nope on trueness, right? So this is nope over here. So my solution is between -4 and +8. And how you write that answer is we had x, right? So x is between equal to -4 and equal to 8. So x is between -4 and 8. Do you guys remember we did those a while back? And we wrote that. So there's my solution. Here's a graph of my solution. And so we did a lovely job on that. These are my test points down here. We'll try another one here. This one doesn't have a typo on it, so that's good. And it's quadratic inequality. And so I have this inequality. And so I'm like, okay, what I need to do is I need to find the boundary. And the boundary happens at equals. And so when I factor this to solve it, this one factors x plus 3, x plus 3. I only get one boundary point. And that boundary point is x equals -3. And I'm going to put that on my number line. Because this is just less than, but not less than or equal to, this is going to be an open circle saying that -3 is really not an answer. It's the boundary between answers and non-answers possibly. So now I want to test points to see where my answers are going to be. And so I'm going to kind of come down here and test. And you want to test something over here and something over here. So this one only has two things to test. So maybe I'll test x equals -4. In the original equation, x squared plus 6x plus 9 is less than 0. So in -4 goes here. So when I do that, I get 16, take away 24 plus 9. I'm going to use my calculator. 16, take away 24 plus 9 is 1. And so this is saying that 1 is bigger than 0. And that's not true. That's a nope. So nope. So there's not solution, no solutions over here smaller than -3. -3 is not a solution. So let's see about over here. Is values over there a solution? And so on my next guide to test, I'm going to test x is 0. Test whatever you want on this side. And I'm going to test 0 because 0 is nice on my arithmetic. Probably won't have to whip out my calculator to test 0. So I get 9 is greater than, 9 is smaller than 0, and that's nope, that's not true. And so this one has no solution, because over here is not a solution, -3 itself is not a solution, and over here is not a solution, so there is no solution. And since they asked you for a graph of the solution, they have a really silly graph that just shows the number line with nothing on it. And it's really silly. And so anyway, so we did a lovely job on that. But I understand they were trying to follow their directions. Okay, this one has, if you multiplied that all together, which I'm not planning on doing, but if you did, it would end up being x to the third. And so it's actually cubic. But you do the same thing. You solve it by the boundary. That's when 5x times x plus 1 times x minus 1 equals 0. And this is actually going to have 3 boundary points. And my boundary points, they've already factored it for me, so that was sweet of them. My boundary points are when 5x equals 0, so that's when x equals 0. When x plus 1 equals 0, so that means x is negative 1. And when x minus 1 is equal to 0, that's when x is 1. So those are my boundary points, and I'm going to put those on my number line. So it wouldn't be good to pick my favorite point, negative 0, on testing. And I want to test in this original inequality there all of my places. And this is a time in my life when I know more room, right? I've been making that on all of my note packets, have that listing on them. And so I'm going to do my testing on a different piece of paper because it's just not gonna fit on here. So I'm going to be testing my test points, and I'm going to pick x equals negative 2, which is over here. And so this is going to be 5 times negative 2, and then negative 2 plus 1, and then negative 2 minus 1 is greater than 0. And then what they do in your book is really, really, really clever. And they say that they're just kind of looking at the signs, because if I'm compared to 0, then I want to know, is it bigger than 0? Well, positive things are bigger than 0, and negative things are not bigger than 0. So all I really care about is this positive or negative? And I can figure that out without figuring out what number it is. And then there's some people that are like, oh, that would drive me crazy. See, when I put these two together, it's negative. I know, negative 10. And when I look at this, it's negative. And when I look at this, it's negative. And when you multiply a negative times a negative times a negative, you get a negative. And a negative is not bigger than 0. So this is nope. In this region over here, nope. Now, if you're like, that would drive me crazy, if you figure out the number, don't do that, then that's great too. You can certainly do that and figure out what number you got there. See, that's negative 10. That's negative 1, that's negative 3. So I think the number 10 times 3 is 30. I think it's negative 30 is the number. Well, negative 30 is not bigger than 0. So whatever. It's pretty good. So now I'm going to test something in between. So x equals negative 1/2 would be between negative 1 and 0. So I'm going to have 5 times negative 1/2, negative 1/2 plus 1, and negative 1/2 minus 1 is greater than 0. And I want to know, is it true? And I'm going to, oops, I got off my paper and wasn't writing that. I'm sorry. And so I put in to the original inequality negative 1/2 everywhere for x. And I'm going to be circling that, and I'm going to be saying that's negative. In here, now negative 1/2 plus 1, that's positive. And this is negative. So when I multiply a negative times a positive times a negative, I get a positive. And every positive number is bigger than 0. And so this is a true region. So the region that goes between negative 1 and 0 is true. It's part of the solution. Oh, I forgot to put my open circle, closed circles. What are they? They're open. So let me put my open circles on here. Open circle, open, 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 right? And so that part is a solution. Okay. Then we want to look at the next region, and I'm going to test half. I'm going to be careful not to get off the paper. So here I am testing 5 times half plus 1 times half minus 1 greater than 0. So this right here is positive. This right here is positive. And this right here is negative. And a positive times a negative is a negative. And a negative is not bigger than 0. So this is a nope region here. If you're saying, does it go every other region? You might be thinking that. Well, on the last problem we did, there was 2 regions right back to back that were nope, right? Nope, nope. And so the answer is no, it doesn't go every other region. Do some of them go every other region? And the answer is yes, they do. And in Math 1, you'll have a theorem that goes with that to tell you when they're going to go every other region. I almost coughed and then I stifled it. Okay, so the next point that I'm going to choose to test is I'm going to test something over here, like 2. So when I test x is 2, then this is going to be 5 times 2, and 2 plus 1, and 2 minus 1 is greater than, so back in the original is where you're testing, right? And I'm just on the sign. You could do the number if you wanted. So this is positive, and this is negative. So since I have it compared to 0, I can do this. If I didn't have 0 on that side, I would not be able to do this. And so, and this is positive as well. And when you multiply 3 positives together, you get a positive, and that is bigger than 0. And so this is a true region over there. So this is a true region. So my solution is trapped between, and I want strict inequality, -1 and 0, or my solution is bigger than 1. So there's my answer. So I have infinitely many answers, and my answers are all between -1 and 0 and bigger than 1. And so we're going to have, if you're thinking, boy, that's awkward, how you have to write that, we're going to have a better way of writing that in Chapter 10. So it's coming. Okay, so we did a lovely job on that. And so I'm going to put no room to test points. Yeah, it happens, right? And I apologize about that when you're trying to fit it on there. So people add their own paper. That's what I've been doing here, is adding my own paper. And I'm going to add my own paper for the next example, probably to test it too. Maybe it'll fit in the region, I don't know, but I'm going to get paper out just in case. So I'm noticing that this is quadratic inequality. So I'm saying, well, the boundary happens at 14 minus x squared equals 5. So I could use, it's quadratic, I could use the square root method to solve it. And so I could take away 14 to get x squared by itself on one side. So this would be negative x squared equals -9. Right? And then I could divide by a -1. So I get x squared equals 9. And then I could do the square root property. So I get x equals plus or minus the square root of 9, which is x equals plus or minus 3 for my boundary points. So on my number line is going to go -3 and +3 with open circles because this is open. And now I've got the regions to test, and so I'm going to test them. And so here's my test points on this one. I had to go on a different piece of paper in order to get them in. So I'm going to test x equals -4. So this is 14 minus x squared is greater than 5. So I'm not going to be able to do this with the positive-negative thing unless you got 0 on one side. Then you could do it like that if you liked. So I'm going to put in -4 here. And when I do this, this is 14, take away 16, which is -2. And -2 is not bigger than 5. So this is a nope in the region. So this is nope over here. Then I'm going to test something in between, like x is 0. So this would be 14 minus 0 squared is bigger than 5, so putting in 0. So this is 14 is bigger than 5, and that's true. So the middle is a region, a solution region. And then last but not least on my testing for this problem is to test for something over here. So 14 take away 4 squared, bigger than 5. And for the same reason, that's going to be -2. And so this is nope, that's not going to work. And so my solution is just in between, is where my solution is. So we did a lovely job on that. All I have to do is write that in notation, right? And so since it's in between, my x is in between -3 and 3. We did a lovely job on that. Okay. So the next one is for rational inequalities. And rational inequalities, I don't know if you remember, but rational expressions are like 1 over x. They're fractions, or maybe more complicated than 1 over x, but they're fractions. And so the first thing that you want to do is you want to solve the boundary point. Let me start again. When you have rational expressions, it doesn't matter what order that you do them in. I said you want to start with the boundary points, and that happens at equals, and find them. That's wonderful. It doesn't matter 1 and 2, what order you do them in. But the other thing you want to do is you want to find the values that make your rational expression undefined, and you want to put them on your number line with an open circle. Undefined is when the denominator, this got all kind of boogered up, when the denominator equals 0. And so you have a fraction, and so there is a place where the denominator is equal to 0. Then you put your boundary points on your number line, and you put open circle or closed circle for them, depending on if it was greater than or equal to, or less than or equal to, or greater than or less than. And so these go with solid circles, right? And these go with open circle. This goes with open circle. It is open. It is never appropriate for the denominator to be equal to 0. Then you do the same thing that we were doing, is you test points in every single region. You cannot test your boundary points. You can't test, so you don't test your endpoints, but you test points in every single region and determine whether it's true or if it's false, and test every region. So we're going to give a try to those and see how we do. I have 3 problems and not enough room, I'm sure. And so I'll be doing, I'm sure I will be doing the same thing I had to do over there. Okay, so I noticed that this is rational inequality. So I know that I need to, the steps, I need to see where it's undefined. And that's where the denominator equals 0. And in this case, that's x plus 4 equals 0. And that happens at x equals -4. And I'm going to have that as an open circle on my number line, right? And then I also want to know the second step, if you will, is the boundary points. And that happens at equals. That's when 1 over x plus 4 equals 0. And so you would solve this by either cross multiplying would be fine, or by multiplying by the denominator. So if I multiply by the denominator, I would be multiplying by x plus 4, both sides. So 1 over x plus 4, and I'm going to multiply this by x plus 4. And on the other side, I have 0, and I'm going to multiply that by x plus 4. So on this side, I get 1. And on that side, 0 times x plus 4 is 0. So this doesn't give any solution. 1's not equal to 0. So I'm not going to have anything I get to put on my number line from the boundary, no boundary point. So it doesn't mean that there's no solution to the whole problem. So maybe I should say no boundary point. And now I'm going to put no boundary point. I can't believe I thought that the work would fit here. And so now on my number line, I'm going to have just -4, and it should be an open circle. And I'm going to now test the points. And so I'm going to do a little test on my paper here, and to get it going. And so I'm going to test x equals -5. In the original, which was 1 over x plus 4 is greater than 0. So I'm going to be plugging in -5. So this is 1 over -5 plus 4 is greater than 0. So this is 1 over -1 is greater than 0. And, sorry. And all I care about really, because it's compared to 0, is it positive or is it negative? And so since it is negative, negative's not bigger, right? This is negative. I don't care what it is. That's not bigger than 0. So this is a nope in my region. So this is a nope, 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 nope. Okay. And then I want to test the other side. And I'm going to be testing 0. I can test anything I want on the other side. So I'm going to test 0. Back in the original here. So 1 over 0 plus 4 is bigger than 0. I want to know, hey, is this true? This is 1/4 is bigger than 0. And all I care about is that this is positive, and a positive value is bigger than 0. So this is true. So another example of it not going every other region. Oh, this one is an example of it going every other region, sorry. And so our answer then, so true, our answer, we had x's that we were solving for. X has to be bigger than -4. And there's our answer. So we did a lovely job on that. Okay. And so that was kind of that story. And then our next one here, and I already know more room. If you're a person that didn't print these, and you could be, I mean, we could have probably fit this all over in the corner or whatever have you, and written really, I'm writing also bigger in order to make it show, and so on the video, and so maybe it fits for you. I don't know. I'm going to stop complaining about it. Okay, so step 1, because this is, again, rational inequality, is to look at where it's undefined. And that's where the denominator equals 0. And that's at x plus 4 equals 0. So that's at x equals -4, same as this one. And so this will be open circle when I put it on my number line at -4. Now I want to know, where's my boundary point? And on the last one, we didn't have a boundary point, but you're going to notice something different on this one. So the boundary happens at equals. So when I multiply both sides by x plus 4, like I did on the last one, so here times x plus 4, and here times x plus 4, here I get x minus 2, and on that side I get 0, just like I did. But that can be true, right? All I'd have to do is add 2 to both sides. So I'm going to add 2, and so I get x is 2 as a boundary point. And because this is greater than or equal to, this is going to be a solid circle on my number line. Okay, so this one is always open, and this one is open or closed depending on what you have here. And so I'm going to have one open and one closed, and that's okay. So now I'm on my third step, which is to test points. So I'm going to put my number line down. I'm going to put -4 on my number line and it's open, and I'm going to put 2 on my number line and it's closed. And make sure that you do this in numerical order. Sometimes I look down and I don't have them in numerical order, and then it doesn't make sense. So make sure that you do it in numerical order. And now on my scratch piece of paper, I'm going to test, back in my original, 3 things. So I'm going to test x equals -5, because that's over here. And my original looks like x minus 2, x plus 4 is smaller than or equal to 0. So I'm going to be putting in there -5. And actually all I care about is it positive or is it negative, because it's compared to 0. And the numerator there is negative divided by a negative. So I have a negative over a negative, which is a positive. And a positive is not smaller than or equal to 0. And so this region is a nope. Nope. And then in between, I might test x is 0. Happens to go in between there. So this would be 0 minus 2, because remember it was back in the original x minus 2, and 0 plus 4 is less than 0. And all I care about is the sign on this. So it's a negative divided by a positive is a negative. Is a negative smaller than 0? And the answer is, yeah, true. It is. So this region in between was true. And then I want to test something bigger than 2, like perhaps x is 3. So 3 minus 2 and 3 plus 4 is less than 0. So we're testing back in our original equation. And I all care about the sign. Positive divided by a positive is a positive. But a positive is not smaller than 0. So this is nope in this region. And so nope over here. And so then my answer is just in between. And it was for x. And compared to this one, I should have just the less than symbol, -4, because it was open. And between here, I should have the less than or equal to symbol 2. So x is greater than -4, but x and also x is smaller than or equal to 2. We're going to have some other notation for writing these, and so that'll come in chapter 10. Okay, so we did a good job on it. We have one more to do, and then we'll be all done with chapter 9, and so I'm happy about that too. And so here we care. It's a rational inequality, and so we care about where is it undefined. And undefined is where its denominator is equal to 0, which is in this case is x minus 2 equals 0. So that's at x is 2. And it's always open where it's undefined. Then I care about the boundary. And the boundary always happens at equals. So in this case, that's 1 over x minus 2 equals 1. And how I'm going to solve that is either by cross multiplying or by multiplying by x minus 2. So I'm going to multiply here by the denominator x minus 2 and multiply over there by x minus 2. So when the dust clears, I get 1 equals, and when I distribute, x minus 2. And I can solve that easily for x by adding 2 to both sides. So I took it out of fraction form, got it into, you could use cross multiplying to do that as well, and got it into something that's just simply linear, and I'm going to add 2. And I get x equals 3. And then this is open or closed depending on what you have there. And so in this case, because I have that, it's going to be closed. Circle on that. So now I'm going to put these on the number line, and it's important that you put them in order. So 2 is smaller than 3, so I'm going to have 2 first on my number line. This is step 3, and 3 on my number line. And this should be open, 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 and this one should be closed. And then the last step is to do the test point, okay? And so as I go to do my test point, I'm going to have room on here to do my test point. I'm going to do my testing over here. Test points, I'm going to test x equals 0. That's in this region over here, in the first region. And so in the original inequality, that's 1 over 0 minus 2, and that's less than 1. So this is -1/2 is less than 1. And that's true. And so this region over here is true. Then I'm going to test something in between, like 2.5. And so I'm going to put 2.5. 2.5 I'm going to put. So this is 1 over 2.5 minus 2. Is less than or equal to 1. Notice I can't just do positive, negative here because I don't have compared to 0. And so, so this is going to be 1 over half, 1 over 0.5, less than 1. And then you could use your calculator to do 1 divided by 0.5. That's 2, though. And 2 is not bigger, so this is nope. Not bigger than 1. So in the between is nope. And then I'm going to try something after 3. Perhaps I'll try 4. So this is going to be 1 over 4 minus 2 is less than or equal to 1. And so that's 1 over, 1 over 2, right? When I put in 4, 1/2 less than or equal to 1. And that's true. Half is smaller than 1. Oh, shoot, it's going to go to 2 videos without me choosing where it went. Darn it. Okay, so this is on part 2, and we were finishing this problem here. And so now all I have to do is write it. And so my solutions are here and here. So I'm going to have 2 different solution sets. So my solutions are smaller than 2, or my solutions are greater than or equal to 3. And then that's it. And so this one's a 34-second video to finish the problem. Oh my gosh, I can't believe it. Okay, bye.